You know, for all of human history, literally everything we've ever known has happened right here, on this one planet. It's our cradle. But in this explainer, we're going to journey way beyond that home base to see just how extreme and how beautifully alien the rest of our solar system truly is. The visionary rocket scientist Konstantin Tsiolkovsky put it perfectly. He said, Earth is the cradle of humanity. And it's so true, right? It's the only environment our biology has ever known, the one place where everything just feels normal. So, what does lie beyond the cradle? Let's step outside and take a look around the neighborhood. Trust me, it's a journey that's going to completely redefine what home even means. Okay, before we blast off, let's just ground ourselves here for a second. Everything about us, the way we breathe, the specific mix of air, the pull of gravity we feel under our feet, even the way our eyes see color under our yellow sun, it's all perfectly fine-tuned for Earth. This is our standard, our biological normal. All right, now that we've got that baseline in our heads, let's start our tour of the solar system's most extreme spots. And you're about to see just how fast the rules of normal get thrown right out the window. First up, the hottest planet. Now, logically, you'd think Mercury, right? I mean, as you can see, it's the closest to the sun. But because it has almost no atmosphere to trap any of that heat, it's actually not the winner. The surprising champ is Venus, and the reason is all about its crazy atmosphere. Get a load of this number. That is the average temperature on the surface of Venus. It's hot enough to melt lead. Its thick, crushing atmosphere is almost all carbon dioxide, and it traps heat in this runaway greenhouse effect that makes the whole planet hotter than a blast furnace, everywhere, all the time. So Venus is just consistently unbelievably hot. But what about the wildest swings in temperature? Well, Mercury takes the prize on that one. With basically no atmosphere to hang on to any heat, its surface goes from a scorching 430 degrees Celsius in the sun down to a frigid -180 in the dark. Mars has similar day-night swings for the same reason, a super thin atmosphere, but they're just not as violent. Okay, let's switch gears from heat to wind. Take a look at this speed. Just let that sink in for a second. 2,100 kilometers per hour. I mean, where in the universe could you possibly find winds moving that fast?
That, believe it or not, is the wind on Neptune. And yeah, it's supersonic. What's so baffling to scientists is that Neptune is incredibly far from the sun. It gets very little energy. So what in the world is driving these impossible winds? It's a huge mystery, and it points to some kind of powerful, unknown heat source deep inside the planet itself.
And hey, speaking of storms, we have got to talk about Jupiter. Its great red spot isn't just a storm, it's a colossal swirling vortex that's whiter than our entire planet. And we know it's been raging for at least 3 centuries. Just try to imagine a hurricane, bigger than your whole world, that lasts for generations. It's mind-boggling. These insane weather extremes are tied directly to another aspect of our solar system that is just hard to wrap your head around. The pure, staggering scale of it all. Here's a number for you, 1,300. No context, just the number. What could that possibly represent in our solar system? That's it. That's how many Earths you could pack inside of Jupiter. It is so massive that it contains more than twice the mass of all the other planets combined. This isn't just a bigger planet, it's a completely different class of object altogether. So to really get a feel for this, let's bring it down to a human scale. Imagine the sun is the size of your front door, okay? On that scale, Earth, our entire world, everything we've ever known, is just a tiny nickel. And Jupiter? It's a full-sized basketball. That's the staggering difference we're talking about. This chart really lays it out. You can see the inner, rocky planets all kind of hanging out around a value of 1, right? Then look what happens when you get to Jupiter and Saturn. The numbers just explode into the hundreds and thousands. It really is a solar system of pebbles and giants.
Now, these differences in size and atmosphere aren't just abstract facts. They would fundamentally change our most basic senses. What we'd see and what we'd hear would be completely alien.
So, have you ever actually wondered what it would sound like on another planet? I mean, really thought about it? The answer is, well, it's pretty weird. Sound is all about the medium it travels through. On Mars, the air is so thin that sounds would be all muffled and quiet. High-pitched noises, like a whistle, they'd barely travel at all. But on Jupiter, with its thick, hydrogen-rich atmosphere, sound travels way faster.
If you tried to talk, your voice would come out comically high-pitched, like you just inhaled a planet-sized helium balloon. And it's not just sound. What we see is calibrated for Earth's sky. On Mars, all the iron-rich dust in the thin air scatters light differently. So during the day, the sky would be this sort of pinkish butterscotch color. But at sunset, you'd look up and see a brilliant, vivid blue, the total opposite of what we experience at home. So after this tour of fire and ice and colossal scale and just plain alien senses, what does it all mean for us? It kind of forces us to step back and rethink our own place in the grand scheme of things. This all leads to a really fascinating and honestly a pretty humbling idea called the rare earth hypothesis. It basically suggests that while simple life, like microbes, might be common out there, the very specific cocktail of conditions needed for complex life like us, a stable star, a big moon, plate tectonics, is almost impossibly rare. It means we might not just be lucky, we might be an extraordinary exception to the cosmic rule. And that, right there, is the real punchline of our journey. Exploring these hostile, extreme, and magnificent worlds doesn't make Earth seem small or insignificant. It does the exact opposite. It reveals just how unbelievably fragile, precious, and uniquely perfect for life our own planet really is. But if our home is so rare, does that mean we're destined to stay here forever? Well, a really forward-thinking philosophy called cosmism argues the opposite. It suggests that humanity's ultimate purpose is to take the very consciousness that evolved here on Earth and spread it outwards, to become a truly cosmic species. And so that leaves us with the ultimate question. Looking out at our solar system, with all its wild challenges and its incredible wonders, are we meant to stay in the cradle that raised us forever, or is our destiny really written in the stars? It's something to think about.